In lesson 18, the main topic is called adding like terms. And before we actually get to adding like terms, look at this first slide. We first need to know what are terms. And it's really important that you know what a term is so that you can identify adding and subtracting like terms. And all a term is, it can be just a number. So it can be any, what we call a number, sometimes we call it a constant, because a number, if I have the number 4, that is its value. It's worth 4. That never can change. So sometimes we call just a number a constant. A term can be just a letter. So it could be the letter X, it could be letter A, whatever. It can be a combination of a number and a letter, as in 4x. And sometimes a term can be something that looks like this, where it's a combination of maybe parentheses, constants, letters, or variables. And this is what we would call one term. So what are terms? It can be any of these examples that were shown here. Now, what are like terms? Well, as we said before, a term can take many different forms. Now, what do we mean by the word like terms? Well, if I had, say, 2a, and then I had a negative 4a, and say I had c. Now, what I have here is 3 terms. So I have a 2a, which is one term, I have a negative 4a, which is another term, and I have c, which is a third term. Now, only 2 of these are what we call like terms. So what are like terms? They're simply terms that have the same combination of letters. So in other words, notice this one and this one both just have an A. So these are what we call like terms. Now this one, the C, is different from the other two because it has the letter C. Now another example would be, how about if I had 3 BC and say I had a negative 2 CD, and then I had, say, BC. Now, again, I have 3 terms here. Now, only 2 of these are what we call like terms. And the like terms are this one and this one. The reason is because they have the same combination of letters. So in other words, the 2 that I underlined both have B's and C's in them. This one doesn't. This is an unlike term to the other 2. Now, something I want to emphasize, it doesn't make any difference what the number is in front. So in other words, in BC, there really isn't a constant there. Really, we have a 1 there. Usually we don't write 1 just because its value isn't necessarily needed there. So, but I want you to remember that BC means the same thing as 1 BC. And going back to my main point here is that it doesn't make a difference what number is in front of the letters. The numbers don't have to be the same. The letters have to be the same combination. As up here in the blue, I had a 2 here and I had a negative 4. Those don't need to be the same. What needs to be the same is the same combination of letters. So these are what we call like terms. Now, why is it so important to identify like terms? Well, we can only add and subtract like terms. So as I go to the next slide, now on the next slide it says which are like terms. And I want you to write this example down in your notes with the directions, which are like terms. Now the like terms are going to be the terms that have the same combination of letters. So as I look at this, I have XMP in the first one, I have an XMY in the second one, an XMP in the third one. So notice I have the same combination of letters in A and C. Now they're not in the same order, but they don't need to be. So I have an XMP in the A, and I have an XMP in the third one. Now, do I have an XMP in the last one? And I do. So our answer to this is that A, C, and D are all like terms. The one that's different is B. Okay, that is not like terms to the others. All right, in example 2, I want you to write this down along with the directions. Now, since we've just gotten done, describing what are like terms, now let's combine like terms. Let's simplify like terms by adding them. Now, as I look at this expression, a negative 2xy plus 3x plus 4 minus 4yx minus 2x. What I have here is I have 1, 2, 3, 4, 5 terms in this. And I want you to pay careful attention to what I just said. I have 5 terms here. And another way to describe terms is really terms are what I described on the first slide in this video. They're connected by plus and minus signs. So notice that all these 5 things that I just underlined are connected by plus and minus signs. And notice how many things are connected by plus and minus signs. I have 5 of them. Now, those 5 terms, are any of them the same? Now, I'm going to erase the marks that I made because I want to show you a way here that we can add and subtract like terms. Which ones are the same terms? Now, I'm going to underline like terms. So, notice I have a 2xy. Now, do I have an xy anyplace else? I do, right here. So I'm going to put one line under that set of like terms. Now, what else do I have? I have an x. I have a term that has just an x. Now I have another term that has just an x. So I'll put a different set of lines. I'll put 2 lines over those. Now I also have a third type of term that's not identical or like to the other ones, and that's the one that just has a number or a constant. So I'm going to put 3 lines underneath that one. Now the number of lines really doesn't make a difference. It's only helping me to identify in my expression which are like terms. Now what I'm going to do is I'm going to combine the like terms. Now this is the hard part. This is the part that usually you really got to force yourself to follow through with. I'm going to take the terms that I have one line under, and I'm going to combine those first. Now it doesn't matter if I combine the ones with 1 line under it and then the ones with 2 lines. I could actually combine the ones with 2 lines first. That doesn't make a difference. What does make a difference is that I'm combining the ones that are like terms. So I'll do the one-liners first. Now as I do this here, so I'm going to do the one-liners. I'm going to do this one and this one. I'm going to look at the sign in front. Now I've got a -2 of those xy's minus 4 of those xy's. So again, I'm looking at the sign in front. So what's a -2 take away 4 more? So a -2 take away 4. -2 degrees drops 4 more. That's a -4, or excuse me, if we're at a -2 and it drops 4 more, we're at a -6. So I have a -6 of those xy's. Now if I wanted, I could write that as yx. The order really doesn't make a difference. Now I've taken care of these like terms. Now I'm going to take care of the other set of like terms I underlined, the 2-liners. So let's see, I'm going to look at the sign in front. So I have a +3 and then take away 2. So I have 3 minus 2. Well, 3 take away 2 is 1. Positive, right? I said a +1, so plus. So again, +3 take away 2, I get a +1. And notice I wrote +1 to show that that is positive. So I have 1 of those x's then. That's what I get when I combine those like terms. So I've taken care of my 2-liners. Now the only thing I have left is the one that I have 3 lines underneath, and that's just a +4, right? There's nothing I can combine that with. So my final answer is what I've shown here. Now remember, it doesn't matter if I did the 1-liners first, then the 2-liners. I could have done the 2-liners, and I could have got 1x minus 6xy, because notice -6 means a -6 plus 4. I could have done it like that. I could have had the constant first, plus 1x minus 6xy. Okay, the order doesn't make a difference as long as I've combined the like terms correctly. All right, in example 3, same directions. We want to simplify by adding like terms. So first of all, how many terms do I have in this expression? I have 1, 2, and 3, right? There's 3 things that are connected by plus or minus signs. Now, which of these are like terms? So in other words, which of those 3 have the same combination of letters? Well, here I have an XYZ. Here I have an XYZ, right? And again, it doesn't matter that one of them has 2 in front of it and the other one has a -5 or -5 in front of it. What matters is the combination of letters. Then I have this one off by itself, which is different from the other 2 because it doesn't have the same combination of letters. This one that I just underlined with 2 lines is an XY. The other 2 are XYZs. Now, I'm going to simplify by adding like terms. Now, this time I'm going to do the 2-liner first. It doesn't matter. So I cannot combine it with anything else, so I just have the 3XY. Now I'm going to combine the 1-liners. So I have a positive 2. Remember, I'm looking at the sign in front. And when there's not a sign in front of the 2, that means it's really positive, right? So I have a positive 2 minus 5. What's 2 minus 5? What's 2 degrees above 0 drops 5? That's a negative 3 of those x, y, z's. And I could have wrote it as a minus 3 y, z, x. Okay, it doesn't have to be in that same order. Now, if I say I would have combined the 1-liners first, my answer would have been a negative 3x, y, z. Now, what sign would go here? What is that 3 positive or negative? Well, there's not a sign in front of it, which means it's positive. So I'd have plus 3xy. So both these answers are exactly the same answer. They mean the same thing. Now, something I do want to note is on the top one, I could have written this as plus a negative 3, like that. But notice that I've kind of got 2 signs. I've doubled up on signs a little bit. It's not wrong, but the best way to write that is just simply minus 3. And that's the simplest way to write it. All right, example 4, again, simplify by adding like terms. The only way we can simplify this is by combining like terms. So the first thing I'm going to do is I'm going to identify my like terms. Let's see, I have a YAC. Here I have a YAC. And this one's different because here I just have an AC. Now I'm going to combine my 1-liners first. So I have a positive 3 plus 6. Let's see, 3 plus 6 is 9 of those ACYs or YACs. And then I have this one that's by itself with a minus sign in front of it, meaning it's negative, 2AC. And I'm done. Now, something else I do want to emphasize here. Why can't I take 9 minus 2? I have 2 terms here, right? Are they like terms? No, because one of them has AC, the other one has ACY. I cannot take 9 minus 2 because I can't add or subtract them. They're unlike terms. I can't do that. Look at our final example. And before I start with this, I want what number really is in front of the x? Remember a little bit ago on that slide, what number is in front of a term if there's not a number? Well, remember, there's really a 1 there. Now, let's identify the like terms. So I've got let's see, I have a constant. Do I have any other just numbers? No. I have just an x, and then I have xy's. So all the lines here are helping me to organize which are like terms and which aren't. Now this is probably becoming a little redundant, but does it matter which like terms I combine first? No, it doesn't. So I'll just go in order by the number of lines. So I'll do my 1-liners first. So I have a 4, which I cannot combine with anything else because there are no other just constants. Now I'll do my 2-liners. Look at the sign in front. A negative 1 plus 3. Negative 1 below 0 goes up 3. That's a positive plus 2 of those x's. Now I've taken care of my constant. I've taken care of my x's. What's left for like terms? Well, I have my 3-liners or my xy's. So I've got a minus 2, negative 2, minus 7. So in other words, a negative 2 minus 7. 2 degrees below 0, drop 7 more. That's a negative 9. Now remember, you could have wrote it as plus a negative 9 like that. But in math, it's best if you don't double up signs. So the best way to write that is minus 9 of those xy's or yx's. Now what's another way I could have wrote this if I didn't combine them by 1 line, 2 line, and so on? There's a lot of different ways I could have wrote this. I could have had 2x plus 4, because that 4 is positive, right? Minus 9xy. I could have had the 9xy first. Let me put it in a different color. I could have a negative 9xy plus 4 plus 2x. Okay, various ways I could have written this final simplified answer. So, 3 things in this lesson. What is a term? What are like terms? And then how do we add and subtract like terms?